Today we'll be talking about neural networks. There is many neural networks for LLMs, as there is convolutional neural network, good for image recognition, and long short-term memory networks, which is good for speech recognition. But today we'll be talking about the plain vanilla multi-layer perception neural network, which would be this one. Neural networks is combined to so basically every little circle here is a neuron. It's like the same thing as the mind. And the brighter they are, it means they are activated. And basically, the brighter they are, it's like a coloring book. It's like you choose which one, whatever the number is related to the color of the table of contents, it will be colored in. So I see one is a full bright white, but like if it's like midway, it'll be like a gray. Neural networks could be spanning to any size, but this one right here is gonna be 28 by 28, which is 784 neurons. Right here is the neural network layer, multi-layers, which should be this is the first layer, second layer, third layer, and fourth layer. They could span from multiple layers, but for now we'll be doing four, which will make sense later. But basically, each layer will have, so this one is like the last image, which is 784 neurons, but it's like verticaled at this point. Then it'll get smaller in the next layer, and then smaller in the next layer, and smaller in the next layer. And the reasoning for it getting smaller and smaller is because in each neuron, this neuron will be hitting each one of them. So each one of these will get a neuron attached to it, and it will kind of like turn brighter depending on if it's hitting, if it's basically been colored in. So on this side right here on this layer, you can see that there is like images, like a line right here, line right here, line right here, right here. It's like sending for all of them, and there's a big circle right here, and it's yellowed. Which we're gonna use this image. We're gonna be doing nine. You see here, it's yellow. So in a world where we have nine, some of these will be bright white because it's like as we see here, it'll be this images will be the same over here in this images, but it'll be like more kind of more like smaller as it would be like this one will probably have like how this has a big circle, it'll probably be like a corner of a circle. So it'll be like depicting of chunks. It'll be chunking basically of this layer. This layer will be the chunk layer. This next one will be the full chunk layer into which it'll give you the number. So maybe this one will be like a corner right here and it'll be white. So it'll hit this one because it's right there. And it'll probably hit this one because it's also the same spot. But in the world that we're in right now, this chunk layer will hit here, which will give us this one. So this one will be full bright white. This one will probably be, and this one will probably be gray. And as you see here, we have this little J letter. So we're also going to hit this one, which will be a white. This one will be white. This will be white. Some of these will be full, will probably be grayish. Some of them will be blanked. And since we have full white here, it's going to go down saying, oh, I remember this image, this nine, it's going to tally to a nine. So we're going to go hit this neuron, it's going to hit to this neuron, and this neuron is going to hit to this neuron. Which basically is, it's like this whole network layer is hitting multiple steps to get to the bigger picture. The way they do it is also through a math function called sigmoid, where they have weights and biases. Be shown on the picture would be the green would be weights, and the biases would be red. The way how the bias will also be at the end of the formula here. See here, this one is in this neuron, it has a stronger bias. Same with this one, same with this one, same with this one. But the bias is like it's basically cutting the edges off the picture. All the green weights will basically be we want this part only. And in this picture, which gives us a clear information of the neural network would be this one right here is the full picture. So we this is the colored in book. This right here is where it reads the chunks of the book. We see here, you see this is green, this is red, blue, orange. but it'll grab these chunks and do another chunk finder. Oh, this chunk was here, so like, so this one could be the top part. Oh, right here. Like how I said, oh, this green one is this one. It goes over here. Yellow goes here. Boom, boom, boom. Okay, repeating until it finds its chunk, which will then end at 9. But basically, the neural network is like a mind. It's like a picture within a picture of a picture as you gradually are building up to find that certain thing, which could also is how we have with the voice recognition. And the way how voice recognition would work would be the same thing, where it would get the voice, like the full audio file, cut chunks, chunk, 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 and then it'll match the speech patterns. It'll like break it down like syllables, and it'll get you like the word. So basically, in the end, the neural network is like the mind. You find the mind, it's full of neurons, and it breaks it down. That's it.